Hello, everybody. I'm redoing, or I should say, supplementing my first integral video, of which I solved a integral that can be easily solved using the beta function. I did it while I was at UCI with Dr. Payam and Blackburn Redpan. Link to the actual general solution will be below if you want to go check that out. But for right now, I'm going to show you how I found a way to solve some of the answers in this integral family using a nice integral trick. So start with the actual integral right here, which is the integral from 0 to infinity of x to the n plus 1 raised to the negative g power with respect to x. And we're going to call this I of ng for simplicity. And our goal is to be finding I of n g plus 1, and however it relates to some constant, which I'm going to call gamma, uh, and the original function I. So the way I'm going to do this is going to be through using integration by parts, because there's actually a very, very simple way to do this. So if you know the function, which is f of x, and that's going to be x to the n plus 1 of negative g for us, f prime of x for this is going to be negative ng x to the n minus 1 of x to the n plus 1 negative g negative parentheses g plus 1 end parentheses, like that, how I summarize it right there. And so we're going to take that and use that in integration by parts. So differentiate, integrate. Now we have f of x, f prime of x. And obviously, since we use the whole function, we're only going to have one as our integration function that we're going to use. And so obviously that's going to give us x. And so now let's do the basics of integration by parts. So now you're going to be left with x times f of x from 0 to infinity, and then minus the integral from 0 to infinity of x f prime of x with respect to x. And so now let's plug all these values in that I just solved. So plugging this in right here, we're going to have x, I believe, where is it? Yeah, x over x to the n plus 1 over g. That's going to be from 0 to infinity. And this is going to be very, very, very similar to what our goal integral is. Okay, as you can see, we have this left side, which we're going to have to figure out what happens at x goes to infinity, which you can easily solve using L'Hopital. And all you have to pay attention to is of x over x to the n of the g, limit as x goes to infinity. And you'll see that this goes to 1 over infinity, which equals 0. And if you plug in x equals 0, you'll get 0 over 0 to the n plus 1 over g, which will be 0 over 0, or well, not 0, 1. So you get 0. So this first part right here is actually just 0. So now what we're left with, oh, my bad, that actually should be plus because of that negative sign right there. Now all what we're left with is that I and g now equal to, oh, I forgot this too, ng right there. Now equal to ng, integral from 0 to infinity of x to the n over x to the n plus 1 to the raised to the g plus 1 power, again with respect to x. And so now, if we add 1 and minus 1, we can actually simplify this. So we get ng integral, you have your actual original integral, and then minusing over 1 back to x. So now you have I of ng, those ngi, and then minus ng of, oh, actually, I'll just go of I and g plus 1 I guess I should just add that here too. And G. Now you have I and G. If you do all of the math, you get this, which isn't that bad. So now, let's say you wanted to solve an integral from 0 to infinity of x squared plus 1 to the fourth like this. Okay, so obviously this is going to be I 2, 4. And we already know that I of 2, 1 is going to be equal to pi over 2 because that's just a basic arctangent integral. So all what we're going to have to do is we're going to have to go I of 2, 1 going to equal to I 2. And in this case, that's going to be 2 times 1 minus 1 going to equal to 2, I of 2, 2. Going, so I 2 times 2, 2 times 2 minus 1, I of 2. That's a horrible 2. 2, 3. Now you're going to have 8, 3, I of 2, 3. Was it the fourth? Yep, so the fourth power. You're going to have 8 thirds. And now you're going to have 2 times 3, 2 times 3 minus 1, I of 2, 4. And so now you're going to have 16 over 5, I to the fourth. Therefore, I of 2, 4 equals pi over 2 times 5/16, 5 pi over 32. And just to make sure, I'm going to check this using the handy integral calculator site. I was actually kind of messing around with it with the cubed version. Let me get the final, just do it again. Fourth. Okay. You go 5 pi over 32. 5 pi over 32. So if you guys want to use this for any of your other integral videos, be my guest. You can also use this for some of the uh, fractional values. I believe Black Pen Red Pen has done some of the half integer values, like 1/2, 3/2, 5/2. I believe he did some of those for Lars. By the way, he's doing much better in case any of you haven't heard. Uh, so yeah, I hope this helps you. And it's a nice little integral trick that I learned not too long ago. So hope you enjoy.